Can anyone tell what exactly we did in till the last class?
So solar liquid flat plate collector.
Okay.
Then you gave the characteristics of flat plate collectors.
Okay.
Then so solar pond.
Okay, very good. The solar pond also explained, right?
Yes.
Solar pond, sir.
How many layers was observed in the solar pond?
3.
3 layers.
3 layers. How you are going to differentiate those 3 layers?
So surface zone, insulation zone, and storage zone.
Okay. In which zone the salt content will be more?
Storage zone.
Very good. Because of the density difference,
Yes.
the water having a rich salt content will retain in the third zone itself. There is no separate layer, means additional material added to separate the layers. By density difference only, water has formed 3 different layers, right?
Yes, sir.
Yes, sir.
Okay. Can you tell what is the temperature of the top surface of the solar pond? You can observe.
Sir, I don't remember the temperature.
Always the temperature, yes, here, not only here, anywhere, whatever the water surface which is exposed to atmosphere will be having almost equal to the same temperature of atmosphere. Okay. Any fluid which is exposed to the atmosphere, it will be having the same atmosphere, right? Almost. So we can tell that the atmospheric temperature is identified on the top surface of the solar pond. And what is the temperature observed at the bottom of the solar pond? In the third zone?
So it can go up to 70 to 90.
70 to 90. It will range from 70 to 90. In the complete solar time, means whenever the sun is very hot, it can go up to 90 degree. And if it is not so hot, it can reach up to 70 degrees centigrade. Okay. Can you anyone tell Debosis? Can you tell what is the application of the solar pond? Applications of the solar pond. Debosis, are you there?
Yes, sir.
Yeah. What was the application of the solar pond? Yesterday I shown on video, no? It is used in some plant. The existing solar plant, which is there in Gujarat, is used for some application. Do you remember?
Yes, sir.
Yeah, which is the plant they are used? Don't know. Madhumita? Are you there?
Yes, sir.
Which was the application I have shown there?
So in the video you showed they are used in many of the factories. For example, in the milk factory also it is used.
Very good, very good. See, why I used to show the video is because you learn better by seeing the videos. And you can remember the videos if I shown, those videos will remember for you for the longer time. After 1 month also, if I ask where the solar ponds are used, application of the solar pond, at least you can name the milk industry, right? So because of that reason, I used to show the videos of all the sources of energies. Okay, instead of orally telling, if I show, see, there are in learning, there are 3 stages. One is orally telling and learning by seeing the videos and learning, and the third one is by involving yourself in the particular plant, going there and seeing. These 3 stages are there. Always I prefer second and third stage so that it will retain for you for a longer time. Okay. Rishabh.
Yes, sir.
Whether in the solar pond, can you tell whether the direct, whatever the third layer, it will third zone, the height will be there, whether it will be directly used for rotating the turbine or what?
Sir, it's rotating the turbine.
Yeah, it's rotating the turbine. Whether the same water is used to rotate the turbine or what will happen?
So the steam generated.
Yeah, steam is generated with the help of what fluid? Whether it's from the same fluid or other fluid? Suhel? Suhel? Suhel?
Yes, sir.
Have you observed the yesterday's video?
No, sir, I am new member.
Okay, new to the class.
Yes.
Okay. And Nandan? Nandan.
Sir,
Nandan, have you observed yesterday's video? What they have done?
sir,
No, no,
no, sir.
no. I'll repeat that concept.
Okay, sir.
See, this is a solar pond concept where the energy is taken from this. See, this is the solar pond where this energy is taken. Okay, hot water and the cold water will be taken from the bottom zone only. That hot and cold water will not directly used for the turbine because this water consists of salt. If I use the salty water inside for the turbine, what will happen? The turbine surface or the blade of the turbine may get eroded. So what they will do, they will try to put, they're going to try to send this fluid in a separate cabin, that is called as a heat exchanger. They will supply this to heat exchanger. In the heat exchanger, what will happen? Just a minute, I'll show you. Here, can you see? That is called as an evaporator or a boiler. In this evaporator or a boiler, this salty water will enter and it will go back. Once it is cooled, it will go back to the solar pond. There is no direct contact between the salt water and what is the water is there in the boiler. In the boiler, there is an organic fluid which evaporate much early. Means the hot water which is coming out from the solar pond is around 90 degrees. So this fluid, what is there here, it will get converted to steam just by reaching its temperature to 40 degrees centigrade. It will get converted to steam. So if I supply 90 degrees, just imagine what will happen. The steam will be superheated. The energy of the steam will be more of this organic fluid. That fluid is allowed to pass through the turbine. So the turbine can rotate at higher speed and the organic fluid which you're using is not harmful for the turbine. Okay, again, this will be cooled in the condenser. This organic fluid will be cooled in the condenser and sent back to the boiler again. Here, there are two fluids used. One fluid is this salty fluid, which is there in the solar pond. That will not directly contact for the turbine. It will be flowing inside the pipe. But while flowing inside the pipe, it will go for this chamber called as an evaporator or a boiler. Inside the boiler, we can see one more fluid called as organic fluid. There is no direct contact between organic fluid and this salty water. There is no direct contact because the salt water will flow in a pipeline and organic fluid will be filled in the boiler. So as the temperature of this salt water is 90 degrees, this organic fluid starts evaporating at very low temperature. That is, you can say about 40 to 50 degrees. Once the 40 to 50 degrees it is reached, it will start evaporating and converting to steam. That steam is allowed to pass through this turbine. And once the turbine is rotated, the steam is again taken back. It is cooled, means that organic fluid is taken back and it is cooled in the condenser, then taken back for this boiler. So that cold organic fluid is supplied again. It will get heated up here, again it will supply. This is one cycle for the fluid, that is called organic fluid, and this loop is for the salt water. Is it clear? So there is no direct contact of the salt water to the turbine. Is it clear?
Yes, sir.
Okay. So we are there. We are going to use two fluids. Just once again, I'll show that because the question they'll ask on that, you have to concentrate on those points. See here. Yeah. Here there will be a third layer where the temperature of the third layer is 90 degrees. And this is highly rich in salt. This liquid will be having high rich salt content. Okay. So it is also called as thermal salt water layer. That hot surface, this top surface will be hot and the cold surface, the bottom surface will be usually cold because of natural convection taking place within this region. As the temperature gets increases at the bottom, it will try to rise above so that the above portion will be having higher temperature. That high temperature fluid is passing through this tube. Can you see here the direction? That will pass through this tube and it will enter to, yeah, see here. This hot temperature fluid will enter to this chamber. What is the name of the chamber? What is the name of the chamber? There shown. The name of the chamber is evaporator or boiler. This is the chamber. For this chamber, the water enters. Salty water enters. High temperature salt water enters. So can you see here? That water will not directly going to the turbine. That is just entering the chamber, taking its path and coming back. During this process, 90 degree temperature, what is there here? It will get cooled off. that heat will be taken by this fluid. Can you see? I'll play that. You can see. Yeah. Can you see? The hotness of this fluid, the fluid which is flowing in a pipe, will be taken by this fluid, that is called as an organic fluid, which will boil as early as possible, reaches 40 to 50 degrees centigrade. It starts boiling. Okay. So here at the top surface, we will get evaporated or a steam of this organic fluid. So because of the rise in temperature, this fluid which is flowing in this tube will get cooled, and then that cooled liquid or a cooled water will be supplied back to the pond. Again, heat from the pond is taken, the hot water is taken here. This is the one cycle or one flow of this salt water. Other flow is there, other fluid is there, which is going to eject from the turbine is this organic fluid, which will boil much early than the salt water. Okay, see. Once it is evaporated, it is collected at the top. Then from the top, there is an opening made. From this, the steam, superheated steam of that organic fluid will be passed through the turbine. This is turbine. The turbine will rotate and it will generate electricity. So that steam which is going for the turbine has to come out. No, that steam is taken out here. Can you see here? That steam is taken out and it is cooled with the help of this fluid. Where is that fluid we taken? That fluid is a normal fresh water taken from the top surface of the pond. So that the top surface of the pond will be having only just 30 degrees centigrade, but the steam which is coming out from the turbine will be having higher temperature. So whenever these two get interacted, what will happen? This steam will get condensed, means it will convert into water from liquid form. That liquid will be collected at the bottom, and this water which is coming out from this chamber is get hotted up. It will be hot enough, not more than 35 degree or 5 degree. It can rise and it will be flowing to the top surface. And this evaporated, the steam of organic fluid will be condensed, that is, will convert into liquid form, and it will be sent back to the evaporator chamber. So which is the actual fluids flowing on the turbine? Whether the fluid from the pond is directly flowed to the turbine?
No, sir.
Hello? Whether the fluid which is taken from the pond is flowed to the turbine? No.
No, sir.
The organic fluid which is having the lowest boiling point, you should mention that point. The organic fluid which is having a lower boiling point will eject on the turbine and it will get condensed in the condenser. Again, it will go back to the evaporator. Any doubts in this plant, in this cycle?
No, sir.
Okay, instead of a very simple concept, instead of allowing this hot brain or a salt water to the turbine, what will do? The hotness of that will be taken by this organic fluid. The high temperature organic fluid is supplied to the turbine. Turbine rotates, and the water which is the steam which is coming out from the turbine will be having still high energy. I mean high temperature. That is taken out with the help of this condenser. From this condenser, the hotness of the organic fluid will be reduced. Again, it will supply here. Again, it is increasing its temperature and the pressure. It is supplied to the turbine. Is it clear?
Yes, sir.
Okay, this is our working of the solar pond. You should mention that point. The steam which is ejecting or the fluid which is ejecting on the turbine is the organic fluid having lower boiling point. Okay. Hello.
Sir.
Okay.
Yes, sir.
And these are all the technical points you should mention. And then we'll go for the third type, that is solar photovoltaic. The first type is solar flat plate collector, solar pond, and solar photovoltaic. These are all the three types they are going to explain. They are going to ask. In exam, either you draw this figure or you can draw this figure. Both the figures are accepted to give the marks. Solar photovoltaic, how it is going to work. You can draw this figure and you can show, or you can draw this figure and you can show. Here the concept required for them in exam is the thickness of N region, thickness of P region. See the thickness 0.2 and 300. You can say in millimeter, 0.2 mm, 300 millimeter. That is the thickness of N and P regions, and how the electricity is generated. Okay. Both the figures tell the same thing, but here this is a line diagram. This is somewhat pictorial, colorful. you can easily grasp. N-type silicon, okay, P-type silicon. Always a P-type silicon will be consisting of positive holes, and the N-type will be having a negative electrons, correct? And at the top there will be a glass lens. Whenever if you apply a load, it will generate a electricity. This I have shown the video in the very beginning class, correct? How the solar photovoltaic works. And you have studied this concept in electronics also, correct? Hello? Can you hear me?
Yes, sir.
Okay. I will show once again that video if you want. I will play the video once again. Whether shall I play or shall I skip this explanation? Hello? You have to speak out. Jawhar, Mohit, Nandan, Pawan.
Yes, sir. Hello.
Whether you will explain this concept or what I should do, you tell me. Because you already know how the PN junction works, how the electricity is generated there, how the holes are filled with the, how the holes are filled, all those things you know, right? In electronics you have studied. Yes or no?
Yes, sir.
It is covered or not? Can you explain how it is going to work? In roughly you explain. Whatever if it is missed out, I will explain. How the solar panels are made up of, that is photovoltaic. Solar photovoltaics are made up of silicon materials, right? Purest form of silicon we'll take out and we'll make a wafers out of from that. Those wafers will be able to generate electricity, correct? How they are going to generate the electricity? What is the process happening? Bhumika? No answers.
Yes,
Sir,
sir.
because of radiations.
Because of radiation. Solar radiation falls on the surface of the silicon plates or wafers. Okay, that is okay. How that solar radiation is converted to electricity?
So because of the photons. So the photons are they absorb energy and the electrons within the cell material. They start migrating towards the cell.
Towards which cell? You forgot. Whether it is covered or not in electronics.
No, sir, it's not.
No, in the p-n junction, concept of p-n junction is done, no?
Yes, sir. Concept is done, but the application of that is not done.
No, I am asking about the concept of p-n junction. You tell the p-n junction concept, I'll tell the application. Okay, shall I show one video for that?
Yes, sir.
Yes. Okay. Here, how the silicons are formed, how the wafers of solar panels are formed, how the radiation falls on that, and the radiation which is falling on that, how it is used for generating electricity directly. We'll show here. I'll show with these two videos. Okay. I was saying that no, on that day, I was explaining about the p-n junction. I saw on that day only I showed the video for better understanding. I hope you forgot, right? Concentrate on this video. Okay, this is the solar panels, application of the p-n junction in the solar panel, how they are going to do. Okay, just you observe this application, you'll come to know how the p-n junction works, how the migration of that's migration, what she told, what Bhumika has told, how it is going to taking place, how the electricity is generated, everything you can see. After this video, you have to tell. Okay. Huh? I'll tell the name. Manoj. Manoj?
Yes, sir.
I will play the video. Observe the video carefully each and every second so that you'll come to know how that PN junction works, how electricity generated in the solar panel.
Yes, sir. Okay.
So we can't hear anything.
Just a minute. You can't hear anything?
No, sir.
No, sir.
Okay, okay. Be online. Just a minute. Now?
No, sir.
No, also you cannot hear?
No, sir.
No, sir.
Cannot hear?
No, sir.
Okay, okay. Just a minute. I'll check out the mode. Because I plugged in the earphone. Let's see. What about now?
No, sir.
No,
No, sir.
Just a minute. Be alone.
Purified polycrystalline silicon. These silicon.
What about now? You can hear?
Yes, sir.
Yes, sir. Yes, sir.
This is shown only how the silicon is done. That silicon plate is done. That is not interested for me. For me, after the silicon formation, how it is going to work. That is important. Okay. From here I'll play. The silicon is taken from the sand and converted to 99.999% of purity. Then the silicon wafers will be formed. See.
Wafers. The silicon wafer is the heart of a photovoltaic cell. When we analyze the structure of the silicon atoms, you can see they are bonded together. When you are bonded with someone, you lose your freedom. Similarly, the electrons in the silicon structure also have no freedom of movement. To make the study easier, let's consider a 2D structure of the silicon crystals. Assume that phosphorus atoms with 5 valence electrons are injected into it. Here, one electron is free to move. In this structure, when the electrons get sufficient energy, they will move freely. Let's try to make a highly simplified solar cell only using this type of material. When light strikes them, the electrons will gain photon energy and will be free to move. However, this movement of the electrons is random. It does not result in any current through the load. To make the electron flow unidirectional, a driving force is needed. An easy and practical way to produce the driving force is a PN junction. Let's see how a PN junction produces the driving force. Similar to N-type doping, if you inject boron with 3 valence electrons into pure silicon, there will be 1 hole for each atom. This is called P-type doping. If these two kinds of doped materials join together, some electrons from the N side will migrate to the P region and fill the holes available there. This way, a depletion region is formed, where there are no free electrons and holes. Due to the electron migration, the N side boundary becomes slightly positively charged, and the P side becomes negatively charged. An electric field will definitely be formed between these charges. This electric field produces the necessary driving force. Let's see it in detail. When the light strikes the PN junction, something very interesting happens. Light strikes the N region of the PV cell, and it penetrates and reaches up to the depletion region. This photon energy is sufficient to generate electron-hole pairs in the depletion region. The electric field in the depletion region drives the electrons and holes out of the depletion region. Here we observe that the concentration of electrons in the N region and holes in the P region becomes so high that a potential difference will develop between them. As soon as we connect any load between these regions, the electrons will start flowing through the load. The electrons will recombine with the holes in the P region after completing their path. In this way, a solar cell continuously gives direct current. In a practical solar cell, you can see that the top N layer is very thin and heavily doped, whereas the P layer is thick and lightly doped. This is to increase the performance of the cell. Just observe the depletion region formation here. You should note that the thickness of the depletion region is much higher here compared to the previous case. This means that, due to the light striking, the electron-hole pairs are generated in a wider area compared to the previous case. This results in more current generation by the PV cell. The other advantage is that due to the thin top layer, more light energy can reach the depletion region. Now, let's analyze the structure of a solar panel.
Okay, that is the basics of what you have studied in electronics about the PN junction, how the electricity is generated in PN junction. Now we come for the application. By using that PN junction application from the one PV cell, how it is formed, the entire solar panel is observed here.
You can see the solar panel has different layers. One of them is a layer of cells. You will be amazed to see how these PV cells are interconnected. After passing through the fingers, the electrons get collected in bus bars. The top negative side of this cell is connected to the back side of the next cell through copper strips. Here, it forms a series connection. When you connect these series connected cells parallel to another cell series, you get the solar panel. A single PV cell produces only around 0.5 voltage. The combination of series and parallel connection of the cells increases the current and voltage values to a usable range. The layer of EVA sheeting on both sides of the cells is to protect them from shocks, vibrations, humidity, and dirt. Why are there two different kinds of appearances for the solar panels? This is because of the difference in the internal crystalline lattice structure. In polycrystalline solar panels, multi-crystals are randomly oriented. If the chemical process of silicon crystals is taken one step further, the polycrystalline cells will become monocrystalline cells. Even though the principles of operation of both are the same, monocrystalline cells offer higher electrical conductivity. However, monocrystalline cells are costlier and thus not widely used. Even though running costs of PV cells are negligible, the total global energy contribution of solar voltaic is only 1.3%. This is mainly because of the capital costs and the efficiency constraints of solar voltaic panels, which do not match conventional energy options. Solar panels on the roofs of homes have the option to store electricity with the help of batteries and solar charge controllers. However, in the case of a solar power plant, the massive amount of storage required is not possible. So generally, they are connected to the electrical grid system in the same way that other conventional power plant outputs are connected. With the help of power inverters, DC is converted to AC and fed to the grid. Please support Learn Engineering's
Okay. You understood how the application of that PN junction you studied in electronics is used for generating electricity in a solar panel.
Yes,
Hello?
sir. I have a doubt, sir.
Yeah, tell me.
Sir, in the video, they told that they were connected in series. Why is that, sir?
That they are not mentioned there.
Like, can you explain that, sir?
Yeah. Just once again, I'll play that. You observe that is also explained that why it is done instead of parallel arrangement, why they have done series. Smash. Yeah.
Get collected in bus bars. The top negative side of this cell is connected to the back side of the next cell through copper strips. Here, it forms a series connection. When you connect these series connected cells parallel to another cell series, you get the solar panel. A single PV cell produces only around 0.5 voltage. The combination of series and parallel connection of the cells increases the current and voltage values to a usable range. The layer of EVA sheeting on both sides of the cells is to protect them from shocks, vibrations, humidity, and dirt. Why are there two different kinds of appearances for the solar panels? This is because of the difference in the internal crystalline lattice.
Okay. I hope it is not explained properly there. Means you cannot able to understand. See, always have you observed the series arrangement, how it will be? The series arrangement means the voltage produced from the series arrangement will be addition of all V1, V1 plus V2 plus V3. Correct? I'll show you with a slide. Just a minute. Just a minute. Be online. Yeah, can I see the screen?
Yes, sir.
Just I'll write the formula so that you'll come to know why it is used. Where the series connection is used. Be online. Okay, can you see? So always in series. In series, the voltage total will be V1 plus V2 plus V3, and the current will be in series. I1 current 1 that is equal to current 2 that is equal to current 3. But in parallel arrangement, voltage total will be V1 that is equal to V2 that is equal to V3, V4 so on. But current will be equal to current 1 plus current 2 plus current produced by one cell. You may tell us current produced by one cell that will be equal to current produced by other cell, addition of that. So because of this concept, depending upon the application where exactly we required voltage combination of that or current combination of that, they are going to use. Okay. The combination of what exactly it is expected. So this is the concept happening in series arrangement and parallel arrangement. Okay.
Yes, sir.
Because of this, they have done the series arrangement. So what will happen if what will be the future of that series arrangement? In series arrangement, if any one component burns out or if any one component is not working, then the entire circuit becomes inactive. But in parallel, it won't happen like that. Okay. Okay. I have observed the top layers on that. What is the reason they have placed the top layer on? Yeah, just one example. I'll show you what is the series arrangement and parallel arrangement for better understanding. Just a minute. Be online. I'll show you some figure so that you'll come to know where the application of those two. What will happen if I use a series arrangement and what will happen if I use a parallel arrangement? Yeah. Can you see the figure here? Yeah. Yeah. Can you see this figure?
Yes, sir.
Here. In series, this is the circuit where if one circuit breakdown, if one source or one resistance, we will call it as a resistor. If this is not working, then the entire circuit will be not working. In this, it won't happen like that. If one circuit breaks down, the other circuit also continues to work. Okay. Okay. Can anyone tell why that one more layer at the top surface is added? What is the reason they have added? That is a glass material.
Protection. Protection, sir.
Just for the protection and also to avoid the shocks taken by the silicon wafers. Okay, because of that, the top layer is added. Here, the solar radiation falls on the surface of the glass. As it is a transparent, it can easily transfer and then transfer on the that silicon wafer, and the electricity is generated. Where you were supposed to write, this is all the point what you're supposed to write. If he is asking this solar photovoltaic, especially in this, you're supposed to tell what is the thickness of N region, what is the thickness of the P region. Instead of telling the values, you can tell thickness of N region is small and the P region is more, and which is positive, which is negative, which consists of holes, which consists of positive electrons. All those things you're supposed to tell. Out of these two, which consist of positive electrons? Out of N and P junction? P junction consists of positive electrons, positive holes. And N junction consists of? N region consists of what electrons?
Negative electrons.
Negative electrons. Okay. And as far as possible, the N region should be small because it will provide the deeper penetration of rays to the joining section, intermediate section, right? Or it is also called as depletion layer, intermediate section where N and P junctions are connecting. It is called as where the connection is done, and the depletion layer should be more and more. That is the main concentration here to make the N region less thickness. Okay. Here, the conversion of solar energy into the electrical energy can be achieved by photovoltaic effect caused by the solar radiation. And the photovoltaic effect can be observed in a variety of material, but the best performance is observed in silicon. Okay, if I use a silicon material, the best performance is observed. Since silicon is a tetravalent material, has 4 valence electrons, it produces more. This is some technical word why the silicon material provides a more specific, more performance. After doping these are all you have seen the video and how the PN junction works. Here, what I wanted to tell is how they are going to connect each cells, how they are going to connect, whether they are connected with the parallel or series. How they are connected? Parallel arrangement or series arrangement is done? Series arrangement is done, that you have to mention. Okay. In the direct solar photovoltaic or direct energy extracted by this solar energy. One more video is there. Once I share this slide, you can go through that video also. You'll come to know still better. 1 or 2 times if you see. For all the things I have included 2 videos. For all the sources. You can go all the videos once I share the PPT. Then we'll go for the next power that is called as wind power. wind power. This is a windmill. Have anyone seen anyone visited the windmill station anywhere? Anyone visited the windmill station or a wind power windmills? Anyone? Big up. No?
No, sir.
Nowhere. Have you seen at least from far?
Yes, sir.
Yes, sir.
Where you seen?
Yes, sir. Pune.
Where you seen? Where you seen?
At hilly regions.
At hilly regions. There I written here, windmills or wind power are more maximum you can extract in hilly regions or near the seashores. What is the reason I written these two is, the wind power required to generate the electricity through this windmill is around 12 to 14 kilometers per hour. Remember, the wind speed required to rotate the windmill blade is around 12 to 14 kilometers per hour. Okay, wherever it is not like hilly region, it is not like a seashore. Wherever you find the wind blowing at a speed of 12 to 14 kilometers per hour, definitely I can install the windmill to generate electricity. Is it clear?
Yes, sir.
Okay. That usually it will be seen in hilly regions and near the seashores. Because of high wind blowing or high velocity of the wind blowing, usually in the hilly regions and near the seashores, most of the plants presently installed are near hilly regions only, as well as the seashores. What is the wind velocity required to suggest that place is good for wind power? To the wind plant, 12 to 14 kilometers per hour is a minimum air or a wind speed required to place the windmill. Okay, and these two are the regions where you can see that wind speed which is flowing. And probably wind sources in India, that whatever the source wind speed I told, we can see in Rajasthan, Tamil Nadu. I written the place also. Jammu and Kashmir, you can see maximum wind blowing there, but still not even a single windmill plant is installed there. West Bengal, which is highest wind speed where you can observe, Odisha, Kerala, Madhya Pradesh, Gujarat, Maharashtra. These are all the few places in India where highest wind we can observe. We can include the Karnataka also. Near Chitradurga, most of the windmill plant you can see just by traveling to Bangalore to North Karnataka. If you travel from Bangalore to North Karnataka, there is one place called Chitradurga. There we can see plenty of windmills, not one or two, around 100 of windmills you can see, because the wind speed there is almost, I guess, 8 to 9 kilometers per hour. With that wind speed, they are trying to extract the wind energy to electrical energy. They are going to convert the wind energy into electrical energy. Okay, that is very near. You can go whenever you are traveling towards North Karnataka, you can see that. And near Ballari also, they have installed few plants. Okay, how it is going to work? How the windmill is going to work? First, I'll explain the different parts. These are all the different parts of the windmill. This is called as a windmill tower, or you can call it as a stand, which will be having height equal. The technical specification I included in the next slide. Just a minute. Just a minute. Just a minute. Okay. See now, this is a windmill or a tower where it is called as a support, and this cabin, which includes the various parts of the power generating setup, and this is called as a shaft, and these are all called these two. Usually for a windmill there will be 3 blades for proper balancing. It will be used, 3 blades will be used of aerofoil section. Remember, the blade section for a windmill will be aerofoil. You have to mention this point. The section of blade of windmill will be aerofoil. Okay, and the center portion of this BMI. Okay, the blade, there will be 3 blades for the windmill. All the 3 blades will be connected to a center portion called as hub. Center portion called as hub. Okay, and this portion of the hub is called as nose or a cone, where the wind is entering. Here I shown the wind in the backward direction. Actually, this wind has to flow from this front direction. This only you have to change. Okay, the wind direction you have to change from the front. Once the wind is blowing, first wind will strike the nose. But I mean to say that this is the direction. This is not the direction of wind. You have to reverse this. And these are all the blades. Usually there will be 3 blades, and it will be in aerofoil section. Once the wind is blowing over the blade, it starts rotating. Because of the rotation, the shaft, which is connected to the hub as well as the motor, starts rotating. Then this rotation of the shaft is transferred to the generator, where the electricity is generated. Here the electricity is generated. From here there will be wiring will be made. Which wiring will be done? And it is went through this wind tower, and at the bottom there will be a power station, where whatever the electricity is generated here, it will be taken and stored at the bottom. Similarly, n number of plants, you can see all the power generated from all the plants will be taken to one powerhouse, one major powerhouse, or it is also called as a grid house. And what is the use of this? This is called as a cap, where the cap uses to include the motor, coupling, bearing, all those things, it will be included. And what is this indicates? Wind speed and direction indicator. The name itself indicates. There, velocity meter will be placed. It is called as an anemometer, where velocity will be measured, wind velocity will be measured, and it also shows, this arrow mark shows that in what direction the wind is blowing. So assume that if the wind is blowing in this direction, the blade can rotate. If the wind is blowing perpendicular to you, whatever the screen you are seeing, if the wind is blowing like this, the blade cannot rotate. But this will show wind is blowing in this direction. Means instead of this direction, it will become perpendicular and it will show the wind is blowing in this direction. In that case, what will happen? This entire arrangement of the top surface, the entire top surface will be rotated particularly towards the direction of the wind with the help of this tail fin. Can you see this tail fin? Tail fin. What will happen? If the wind is blowing in this perpendicular direction, this tail fin will be pushed with the help of the fin, with the help of that wind, so that it will be rotating. Here, it is not a rigid connection. It will be easy to rotate. The top surface will be easy to rotate. In the video, you can see that. Because of that, this wind blade, the blades of the windmill will be exposed to the air. And again, it starts rotating and generate the electricity. That is how the windmill or a wind power can be used for generating electricity. See a few points in this. Wind energy is the energy contained in the wind blowing across the surface of the earth. Wind are caused due to uneven heating of the atmosphere by the sun. What is the reason winds are formed? What is the reason winds are formed? Why winds are formed? How it is formed? Because of uneven heating of the earth's surface due to the sun. Density difference will take place in the air. Because of the density difference, wherever the lower density is there, a wind will try to move towards that. During that during the motion of the wind from one place to other place, wherever the wind energy is more, that is velocity of the wind is more, we can install this plant and it can extract that energy. And it is called as indirect form of solar energy. That means we are not going to convert the solar energy directly to the electricity. First, wind energy is, solar energy is utilized by the air. From the air, it is taken out as an electrical. So it is called as indirect form of solar energy. Because wind is produced with the help of the solar energy, means the sun only. Because of the sun only, density difference creates, and then air flows the flow of air takes place from one place to other place. With that, we are taking electricity. So what is the major source of producing the density difference? Major source of producing airflow is sun. So it is called as indirect form of solar energy. And it is renewable, non-conventional, and the first electric plant was installed in 1880. At that time only it was installed only. It is well known from 1880 only. And no device can extract all the wind energy. As you know, only there is a size limitation of the windmill. All the wind energy we cannot extract from one windmill. This is very important point. It has been found that maximum power output of the exit wind velocity should be equal to 1/3 of the entrance. This is entrance velocity. That means if this is the blade, What is the maximum efficiency of this blade? I can obtain only once if assume that the wind which is blowing here is 90 or a 9 km/h. The exit velocity going out from the blade should be 3. Then only 1/3 of the energy has to be will be extracted. That is, input energy is 9 km/h, and 1/3 of the velocity has to go out. That is 1/3 of 9 is how much? 1/3 of 9 km.
3.
So if the exit velocity is 3 km/s, 3 km/h, then definitely we can tell that this is a highly efficient windmill. It has extracted maximum energy of the wind. Okay, so that the difference between the wind velocity at the before windmill and after windmill should be 1/3. If you want to tell, it is more efficient. Okay, and then how it is going to work? I already explained, just I'll read out the points. The wind turns the blade, which spins the turbine shaft. The shaft is directly coupled to the generator where electricity is generated. That means here, once the wind is blowing, this rotates the blade. Because of the rotation of the blade, the shaft rotates, and then it is connected to the motor, electricity generated. Then the energy in the wind turns 2 or 3 propellers. Usually there will be no 2 propeller, it will be 3 propellers, or it is also called as blades. And the rotor is connected to the main shaft, which spins a generator to produce electricity. And wind turbines are mounted on the tower. What is the height of the tower? The height of the tower required is 100 feet. Usually the height of the tower required is 100 feet or above from the ground level. Then only I can extract the wind properly. And they can take advantage of the fast and less turbulent wheel, and the blade act much as an aeroplane wing. That is aerofoil section, I told. No, instead of that aerofoil section, aerofoil section is nothing but a wing of aeroplane. You can see the wings of aeroplane, the section. It is similar to it. And as the wind blows, the pocket of low pressure from this, I'll explain with the figure in the next class. By using iScribe, I'll show that how exactly the wind, once it is blowing on the blade surface, how it is going to rotate. And the important point in this is wind turbine can be used to produce electricity for a single home or a building, or they can be connected to an electric grid for more widespread electricity distribution. I can install the windmill in our home, on the top of the home, but the energy produced from that is very, very less. If I combine n number of windmills, then I can supply that power to the grid, and then huge amount of energy will be generated. And the wind speed at the height of all the blades both contribute to the amount of energy generated. That is, wind speed is also important, and height of the wind turbine is also important to generate electricity. What is the wind speed required? What is the wind speed required?
12 to 14. 12 to 14.
And what is the height required?
100 feet. 100.
100. What is 100 unit? 100 kilometer?
100 feet.
Yeah, 100 feet, or you can also say at 30 meters. Both contributes for extraction of the energy. And these are all the advantages. What is the advantage of windmill? Operation maintenance costs are less. Fuel cost is nil, because we are not going to use any fuel at all here to run, and is not polluting. Helps in generating power to the houses located offshores and onshores, remote areas, everywhere, and reliable at elevated sites. Limitations: noisy during the operation. Whenever the windmills are rotating, you can observe noise. And the large hilly areas are required for large power generation. If I want to generate more and more power, hilly stations I have to search, and needs storage batteries. And fluctuation in amount of power generated due to time and day and location. Always the wind velocity, I cannot expect the same. There will be a fluctuation of the wind. Depending upon the wind fluctuation, the blades also, the speed of the blades also varies. Okay, that is a major drawback. And this is how it works. You see the animation, just a minute. So because of the wind motion, the blade starts rotating. Because of that, electricity generates, and this electricity is supplied for the grid house. Assume that there are n number of windmills, and from all the windmills, the electricity is taken to the grid house. This is called grid house, where the power is distributed wherever it is required. Once it is supplied to the grid house, of course, these two are the consumption source. So the electricity is supplied for these two sources. You can observe here. Now there is no input. Still, output is going on. How come the output is going on without the input? because there is a bad storage system where the electricity stores there and distribute evenly whenever it is required. Is it clear?
Yes,
Can you
sir.
see the Can you see the wind blowing up on the blade?
Yes, sir.
Okay. See the height of the wind, and there is some video. I'll show you that video in the next class. Okay, I'll show the video of that windmill in the next class, so that you can come to know how this tail fin is used to rotate the top surface of this wind towards the direction of the wind. Okay, so next class you prepare a bit and come for this windmills. I can ask few questions on the windmill and I'll proceed further. Okay.
Sir.
Okay. Just a minute, I take the attendance. Bhumika Bhatt,
Present, sir.
Darshan,
Present, sir.
Manoj,
Present, sir.
Mohammed Sahil,
Present, sir.
Shreyas,
Present, sir.
Sai Vikshna.
Present, sir.
Okay, Vijay,
Present, sir.
Debosis,
Present, sir.
Jawar Babu,
Present, sir.
Jawar Babu.
Present, sir. Present, sir.
Okay. Dhananjay Raju,
Present, sir.
Rishi,
Present, sir.
Alok, Nishant,
Present, sir.
Aditya,
Present, sir.
Rahul Kumar,
Present, sir.
Raghu, Pavan,
Present, sir.
Chetan,
Present, sir.
Shivaraj,
Present, sir.
Dobimo, Mohammad Zishan,
Present, sir.
Syed,
Present, sir.
Nikhil,
Present, sir.
Anirudh Ji,
Present.
Pratham,
Present, sir.
Deepak,
Present, sir.
Rishabh,
Present, sir.
Nandan Reddy,
Present,
Nandan
sir.
Reddy, Yogesh, sorry, Madhumita,
Present, sir.
Mohit,
Present, sir.
Vivek, Gaurav, Abhishek, Rahul Singh,
Present, sir.
Atharva,
Present, sir.
Harshavardhan,
Present, sir.
Mohit KM.
Present.
Okay, fine. We'll meet again in the next class.